Have you ever wondered just how vast the Milky Way really is? To grasp its immense scale, we first need to understand the astonishing distances between the planets within our own cosmic backyard, the solar system. But that's just the beginning. Beyond it lies a scale so immense that it dwarfs everything within our solar neighborhood. Our first stop is surprisingly close, yet profoundly important: our moon. Located just 400 kilometers from Earth, this distance might seem enormous, but on a cosmic scale, it's merely a small step. To put it in perspective, imagine boarding a plane traveling at a constant speed of 1,000 kilometers per hour. A direct flight to the moon would take about 16 days of non-stop travel. In terms of communication, light, traveling at an unimaginable speed through space, takes about 1.28 seconds to cover the gap between Earth and the Moon. This means a message sent back and forth would experience a slight but noticeable delay of about 2.5 seconds, just enough to disrupt the flow of conversation and make real-time communication tricky. But as we shift our gaze farther and set our sights on Mars, this delay becomes far more significant. The red planet lies about 56 million kilometers away at its closest approach to Earth. If the same aircraft could somehow chart a direct route to Mars, the journey would take roughly 6.2 years. Light, on the other hand, takes about 3 minutes to cross that distance, meaning a minimum 6-minute delay for two-way communication. In the precision-driven context of space exploration, such delays aren't merely inconvenient, they can have critical consequences. Now, it's important to clarify a point from a previous discussion. We mentioned the Sun-Earth distance, measured as one astronomical unit, or about 150 million kilometers. However, there was some confusion about why this distance isn't a fixed number. The reason lies in the very definition of the astronomical unit. It represents the average distance between the Earth and the Sun, which varies because Earth's orbit is not a perfect circle, but an ellipse. At perihelion, the closest point, Earth is about 147.1 million kilometers from the Sun, occurring roughly 2 weeks after the December solstice. At aphelion, the farthest point, the distance stretches to about 152.1 million kilometers, roughly 2 weeks after the June solstice. Interestingly, Earth is farthest from the Sun during summer in the Northern Hemisphere. A fact that surprises many, since the warmer season isn't due to proximity, but rather the tilt of Earth's axis. Even light, the fastest entity in the universe, takes about 8 minutes and 20 seconds to travel from the Sun to Earth. Venturing deeper into our solar system, we eventually reach Neptune, the most distant planet, orbiting at an average of 4.5 billion kilometers, or 30 astronomical units, from the Sun. At this staggering distance, sunlight takes 4 hours to reach Neptune. When Neptune and Earth align on the same side of the Sun, the distance narrows to about 4.3 billion kilometers. Imagine flying there. A plane traveling 1,000 kilometers each would take an incredible 490 years to complete the trip, vividly revealing the immense scale of our solar system. Beyond Neptune lies a frontier filled with dwarf planets, the most famous being Pluto, around 39 astronomical units from the Sun. Yet even this vast region doesn't mark the true edge of our solar system. That boundary is defined by the heliopause, the outer limit where the Sun's influence gives way to interstellar space, filled not with solar plasma, but with material from other stars. Crossing the heliopause means leaving the familiarity of our solar system and entering the vastness of interstellar space, where distances become truly staggering. The nearest star to our Sun, Proxima Centauri, is about 40,008,000 kilometers away. To put that into perspective, consider an average person taking 700 to 500 steps a day, about 6 kilometers daily. For most of human history, the average lifespan was around 24 years, meaning a person would walk roughly 52,560 kilometers in a lifetime. If we multiply that by the estimated 117 billion humans who have ever lived over 200,000 to 300,000 years, humanity's collective walking distance exceeds 6 quadrillion kilometers, 6,149 520,000 kilometers. If every generation could pass the baton to the next, each walking their share, together we would reach Betelgeuse. Yet even that immense distance would still represent less than 1% of our entire galaxy. In this thought experiment, it would take our species about 2.8 trillion years to traverse the space between the Sun and Betelgeuse. These figures are far beyond everyday comprehension. While we can express or calculate such numbers, truly grasping what they mean is nearly impossible. For example, our galactic home, the Milky Way, spans about 100,000 light-years across. To better comprehend this immensity, let's shrink the entire Milky Way down to the size of Earth, about 12,142 kilometers in diameter. Doing so would mean compressing the galaxy 74 trillion times, precisely 74,248 and 394,856,229 times. In this scaled-down model, our Sun, about 1.4 million kilometers in diameter, would shrink to just 18 micrometers across, thinner than a strand of human hair. Within this miniature Milky Way, our nearest stellar neighbor, Proxima Centauri, would sit just 0.54 kilometers, half a kilometer, away from our tiny Sun. Meanwhile, Betelgeuse, one of the largest and brightest known stars, would be just 82.82 kilometers away. Spanning 100,000 light-years from edge to edge, our galactic home is a realm of incomprehensible vastness. When light last completed its journey across the Milky Way, our hunter-gatherer ancestors roamed Earth, unaware of the cosmic ballet unfolding above them. And yet, as immense as our galaxy is, it's but a single point in a universe teeming with an estimated 2 trillion galaxies, each with its own stars, planets, and potential life, all contributing to the endless, ever-expanding story of our universe.
Centuries, humans thought of the universe as a straightforward place.